Hello everybody, I'm Fernando Nuño with Leonardo Energy and welcome to today's webinar hosted by Leonardo Energy in collaboration with the International Smart Grid Action Network and the Clean Energy Solution Center. Our focus today is on defining what makes an electricity grid smart and a methodology to measure the smartness of the electricity grid. So first of all, some housekeeping announcements. You can introduce yourself using the chat window on the left, as many of you have already done. You can submit your questions through the Q&A window, which is in the lower left corner. We will handle a Q&A session after the presentation. This meeting will be recorded and made available in the web of Clean Energy Solution Center and as well as in the web of Leonardo Energy. Agenda for today, we have a great presentation prepared for you today that is focused on smart grids, defining what makes an electricity grid smart and proposing a methodology to measure grid smartness. We are fortunate to have Leen Vandezande, a postdoctoral researcher in the Electric Energy Research Group, ELECTA, at the K.U.Leuven presenting today. Before Leen begins her presentation, K. Miller will provide some introductory remarks with a short informative overview of the International Smart Grid, of the International Smart Grid Action Network. Then I will talk shortly about Clean Energy Solution Center and about Leonardo Energy initiatives. Following Leen's presentation, we will have a question and answer session. So now, Mackay, the floor is yours.
Thank you, Fernando. My name is K. Miller. I work at the National Renewable Energy Laboratory in the United States. I also support the activity of the International Smart Grid Action Network, or ISGAN. Fernando, is the first slide showing there?
Yes.
Thank you. ISGAN is an international mechanism for cultivating high-level government attention and action to accelerate the development and deployment of smarter electricity grids around the world. ISGAN engages in a number of activities, all aimed at building a more global understanding of smart grids, addressing gaps in knowledge and tools, and accelerating smart grid deployment. It builds on the momentum of and knowledge created by substantial global investments being made in smart grids over the past several years. ISGAN is organized as a task-shared International Energy Agency implementing agreement since April of 2011. ISGAN was initially launched as an initiative of the Clean Energy Ministerial in 2010, fulfilling a key recommendation of the Smart Grids Technology Action Plan released by the Major Economies Forum Global Partnership in 2009. Additionally, ISGAN leverages cooperation with other initiatives and International Energy Agency implementing agreements. Next slide, please. There are a number of national ISGAN participants, as well as a number of countries currently invited to join and actively working to join the International Smart Grid Action Network. A brief list of these countries is presented here. Next slide, please. And finally, there are 6 primary areas of work that ISGAN organizes. 4 of these areas of work have been underway since 2011. These are Annexes 1 through 4, a global smart grid inventory, Annex 2 focusing on smart grid case studies around the world, Annex 3, which focuses on benefit cost analysis and toolkits, and Annex 4, which summarizes the work of the first 3 annexes into synthesis for decision makers. There are 2 new projects under the ISGAN work portfolio. The Smart Grid International Research Facility Network, which aims to align and coordinate work between international smart grid research facilities. And finally, Power Transmission and Distribution Systems, which integrates much of the work of previous International Energy Agency power systems work and advances that work through the International Smart Grid Action Network. There are a number of individuals that you can contact for more information about ISGAN. I am one of them, and Fernando, I believe that my email address can be made public in the recording, and I am happy to answer any further questions about ISGAN. Let me conclude by saying that we are very happy to have Leen Vandezande on the webinar today. I'm very much looking forward to hearing her comments about measuring the smartness of the electricity grid. Thank you very much.
Great. Thank you, McKay. So just to finish the round of introductions, Leonardo Energy is an initiative that unites professionals from all over the world dedicated to electrical power and sustainable energy. Leonardo Energy provides education, training, and the comprehensive exchange of expertise. This slide provides a bit of background in terms of how Solution Center came to be. The Solution Center is an initiative of the Clean Energy Ministerial and is supported through a partnership with the United Nations Energy. It was launched in April of last year and is primarily led by Australia, United States, and other CEM partners, Clean Energy Ministerial partners. Outcomes of this unique partnership include support of developing countries through enhancement of resources on policies relating to energy access, no-cost expert policy assistance, and peer-to-peer learning and training tools, such as the webinar you are attending today. We encourage you to explore and take advantage of Solution Center resources and services, including the expert assistance, subscribe to the newsletter, and participate in the webinars and policy forum. And now it's my pleasure to introduce Leen Vandezande. Leen Vandezande obtained her Ph.D. in electrical engineering from K.U.Leuven in Belgium, with her Ph.D. manuscript on balancing market design and integration. Currently, she's working as post-doctoral researcher in the Electric Energy Research Group, ELECTA, at the K.U.Leuven. Being involved in several European projects in the field of smart grids and in smart grid industry associations, Vandezande is acquainted with research, policy, and market activities in the area of smart grids. Her research interests include European energy policy and energy market design. So, Leen, thank you for joining us today, and now the floor is yours.
Thank you, Fernando. Hello, everybody. So with this presentation, I want to introduce you to a methodology which has been developed at the Catholic University of Leuven in Belgium, which may help you in measuring the smartness of your electricity grid. So to start with, a short overview of this presentation. So first, I will give a short introduction into European energy policy. Then, as the methodology is based on key performance indicators, I will shortly explain what are key performance indicators and why do we use them. And then I will dive into the methodology itself and finally some conclusions. So first, the introduction. So I don't know whether you are familiar with the European energy.
Excuse me, Leen. Can you go
Yes.
through the slides?
Yeah, I'm going through the slides.
Oh, okay, it's still on the first slide. I don't know whether you tried to. Should I go to the next, or are you moving this?
Because how I see it, I'm now on the third slide. If I look at it, or maybe I have to do it.
If you can, yeah, if you can use the controls on the lower left corner, shift to arrow. Yeah.
But then
so
I
that,
don't. Is it now
one
better?
moment. I think you're sometimes disconnected, so I think your internet connection is not working very well. So okay, so I will go through the slides. I think it didn't work properly. So I put here the background European energy policy, right?
Excuse me?
Should I put the slides European energy policy?
Yes. Okay. Okay, and then I will follow on my own slides. Perfect.
Okay.
Okay. So I'm on my third slide now.
Okay. Perfect.
Okay. So, so this slide focuses a little bit on European energy policy. So the European Commission set some targets to reach a low-carbon economy in the far future. So first, they set 3 ambitious targets by 2020, targets which are binding. And these targets are first to cut the greenhouse gas emissions by 20% compared to the 1990 levels by 2020, to reduce energy consumption by 20%, and to reach a 20% share of energy from renewable energy sources by 2020. So they also set a target, but this is so far not binding, towards 2050. So by 2050, Europe wants to reduce its greenhouse gas emissions by minimally 80%. Now, it has been recognized by many organizations and initiatives that to reach these ambitious targets, that a smart electricity grid is a key aspect to reach these goals. So next slide, please. So the European Commission has launched some specific initiatives in which they indicated that smart grids are very important, and they also put a lot of money in the realization of these smart grids. So the most important initiative is a strategic energy technology, or SET plan. So this was a plan that was initiated in 2009, and it consists of 6 initiatives which are listed there. So one focusing on wind energy, one on solar energy, one on electricity grid aspects, one on bioenergy, one on carbon capture and storage, and the last one on nuclear energy. And so what this plan wants to do is to accelerate the development of low-carbon technologies in these 6 areas, but also to stimulate the development to market take-up. So the electricity grid initiative has been further developed so far, and it is now called the European Electricity Grid Initiative. And so it consists now of a 9-year RD&D program, so it's focusing on research, development, and demonstration, and with an estimated cost of €2 billion. So it's a thick booklet with a lot of functional projects in it and clusters, and in each of these functional projects, different demonstration projects will be initiated and will be subsidized by the European Commission. So this is about this SET plan. Then also regulators in Europe are looking at smart grids and are taking initiatives in this respect. So in 2010 there was a first position paper on smart grids written by one of the regulators. And so last year there also was a status review, so looking how different member states are regulatory approaching smart grids. So what the regulators want is to put in place an adequate regulatory framework that stimulates the deployment of smart grids, but that also ensures that the benefits of this smart grid are reaped most efficiently, and that also the final consumer can benefit from it. Okay, so next slide, please. So this was a short introduction to European energy policy. So I said before that the methodology we developed at K.U.Leuven is based on key performance indicators. So very short, what are key performance indicators and why do we use them? So next slide, please. So what are key performance indicators? Well, in general, they are used for performance measurement, so to measure how successful a certain business activity is. So they are used in a lot of business activities like the construction industry, health industry, for quality regulation, electricity distribution systems, etc. Now, in a smart grid context, we do not yet have a common methodology to measure how successful we are in realizing smart grids. But as I said before, we have several initiatives in Europe that want to stimulate the smart grid development. So if we look at the set plan, it would be interesting to evaluate how this set plan contributes towards the 2020 targets. With respect to the European Electricity Grid Initiative, it would be interesting to evaluate how successful each of these demo projects are that are initiated. With respect to what the regulators are doing, it would be interesting to evaluate how the regulatory incentives work that they are putting in place. So, but for each of these evaluations, there is not yet a clear framework existing today. So next slide, please. So why would we use KPIs? So in the context of smart grids, we use KPIs to answer the questions, what makes an electricity system smart? And secondly, how can this smartness be measured? So we will try to quantify how smart a certain electricity system is. Next slide, please. Okay, so let's now dive into the methodology. So next slide. So how has the methodology been defined? Well, we started from 6 characteristics of how of which a smart grid is composed, and these 6 characteristics are derived from a report from the United States Department of Energy. So based on these 6 characteristics, we defined several categories, and in each of these categories, we invented some KPIs that may help to measure how smart your electricity grid is. So each of these KPIs was tested to what they call the SMART criteria, which means that the KPI has to be specific, measurable, attainable, relevant, and time-bound. So KPIs have to be easy and understandable, and most important, it's needed that you can measure them. Okay, next slide, please. So which are the 6 characteristics so that we derived from the US Department of Energy? So the first one is enable informed participation by customers. The second, accommodate all generation and storage options. The third, sell more than kilowatt hours. Then the fourth, provide power quality for the 21st century. Then optimize assets and operate efficiently. And the last one, operate resiliently to disturbances, attacks, and natural disasters. So the aim is that policymakers will stimulate progress in each of these 6 areas, because only if you get a certain level in each of these 6 characteristics, you will realize a real smart grid. So now let's go more into detail into each of these 6 characteristics. So next slide. So the first characteristic consists in enabling informed participation of customers. So in a traditional passive grid, the customer is rather a passive component, but in a smart grid, he will become an integral part of the system. He will get more information, and he will be able to react on this information. So in this first characteristic, we defined 5 categories in which we want to measure progress towards more smartness. So I will go through the categories. So the first one is advanced meters. So as you all know, advanced meters are a key technology in enabling customers. Through these smart meters, customers will get more information, and based on this information, they will be able to make decisions on their energy consumption, for instance. A second one, dynamic pricing signals. Dynamic pricing signals will be used to give certain incentives to consumers. So for instance, real-time pricing tariffs can be used, and based on these real-time prices, customers can decide to increase their consumption, to reduce their consumption, etc. Or they could get certain pricing signals from a network operator, and based on this, they can decide to offer their flexibility to the network operator. Then the third category, smart appliances. So think of a smart dishwasher, for instance, or a smart heat pump. So these appliances will be remotely controlled, and they can also react, for instance, to pricing signals or to signals coming from an operator. So they can also help in reducing the peak load at a certain moment and helping in shifting loads to moments where electricity is cheaper. Then the fourth category, demand-side management. So demand-side management has an influence on energy consumption, so it's certainly a good indicator for the level of active involvement of the customers. Then the last one, prosumer. So as you all know, more and more decentralized generation is coming up, and we also see that a lot of residential, commercial and industrial consumers now have their own generation. So they are becoming what we call a prosumer. So it implies that they are not only taking electricity off the grid, but that they are also injecting electricity in the grid so that you get bidirectional flows. So these are 5 categories that we identified here, and now for each of these categories we formulated some KPIs. So it are these KPIs that have to be measured, and the quantitative results on these KPIs will give you an indication of how smart your grid already is. So next slide, please. So which KPIs did we define for this first characteristic? Well, for the category of advanced meters, we defined 2 KPIs, namely the number of advanced meters installed and the percentage of total demand served by the advanced meters. For dynamic pricing signals, we also identified 2 KPIs, so the fraction of customers served by the tariffs and the fraction of load served by the tariffs. For the smart appliances, also 2 KPIs. So the sales volume for purchases of these appliances, and also the load capacity that can be modified by behaviors of smart appliances. Then with respect to demand-side management, we identified 3 KPIs. So the fraction of consumers contributing in demand-side management, the percentage of consumer load capacity participating in demand-side management, and the potential for time shift. So with which we implied, so with how many hours, for instance, you can shift your load to a later moment because of this demand-side management program. And then finally, with respect to the prosumer, we identified 3 KPIs. So the total electrical energy locally produced versus the total electrical energy consumed, the minimum demand from the grid versus the maximal demand, and the fraction of time the prosumer is a net prosumer, and the fraction of time that he is a consumer. So these are the KPIs in this aspect. So next slide, please. Then with respect to the second category, so accommodating all generation and storage options, we identified 3 categories. So the first one is distributed generation and storage. So as you all know, a smart grid is meant to integrate more distributed generation and also storage facilities. This distributed generation is often intermittent and variable, so we need to develop measures to smartly integrate it and to cover this variability. One means to do this are storage facilities which can offer flexibility. Another means is using this active demand, as we discussed before. So a second category is focusing on a specific type of storage, which is included in plug-in hybrid electric vehicles. So we also want to integrate plug-in hybrid electric vehicles in our electricity grid, and we also want to smartly use the batteries included in these vehicles. And then the last one, data interconnection. So with data or distributed energy resources, we refer to all distributedly connected components, so storage, distributed generation, and also active consumption. But we need a kind of standard interconnection rules to connect these different components to the grid, such that it can be done in an easy and efficient way. So these are the categories, and again, for these categories, we developed different KPIs. So with respect to the next slide, please. With respect to the first category, so the distributed generation and storage, we defined 3 KPIs. So the first one measuring the amount of production generated by this DG elements, and then two other ones focusing on storage facilities. So one focusing on electrical energy storage, and the other one focusing on a new kind of storage, a kind of indirect storage, which can be done through the use of heat pumps. So with heat pumps, you can create a time shift, so similar to active demand, who can shift load. So you can also shift the heat and the heating and cooling of your heat pump, and so shift electricity consumption. Then with respect to the electric vehicles, we identified 4 KPIs. So there is a KPI focusing on the percentage share of electric vehicles. Then there is also 2 KPIs that are indicating how much controllable the electric vehicles are that are integrated in your network. This whether you have control over their charging capacity and whether you have control over their storage, over their battery. And then finally, with respect to the dead interconnection, so the last category, we have 1 KPI identified, which is the percentage of grid operators with standard interconnection policies. Then next slide, please. So a third aspect of a smart grid is the aspect of selling more than kilowatt hours. So in a smart grid, new products, services, and markets will arise. So end users, for instance, will be able to offer their flexibility to, for instance, a network operator. New market players, like for instance an aggregator or a virtual power plant, will arise, etc. So in this characteristic, we identified 5 categories to measure progress in this characteristic. So the first one is new energy services. So in a smart grid, a lot of new energy services will arise. For instance, services with respect to improving energy efficiency at your home level, to optimize your energy bills, etc. And these services will be typically offered by an energy service company or ESCO. So this is the first category. Second category, focusing on flexibility. So in a smart grid, new market parties will arise that will collect flexibility from different components connected to the smart grid. So you will get this kind of aggregators, which are intermediate parties that are connected with, for instance, active demand, with storage facilities, and also with different types of generation. They will kind of collect the flexibility available in each of these components, and they will go to the market to get the best price for this flexibility. Then the next category, customer choice. So in a smart grid context, the idea is that customers will be able to choose between different types of supply. So for instance, they can opt for green energy only. They want a supply at the lowest cost. They want a supply with 100% reliability or only with 80% reliability, etc. A fourth category focuses on a support mechanism. So if we want to install a smart grid, and if we want different parties to invest in certain elements of the smart grid, we need a kind of regulatory framework that stimulates investments, and we also need appropriate funding, so also public funding to realize certain aspects of the grid. And then last category, the interoperability maturity level. In a smart grid, communication, for instance, is very important. So we need a kind of standards on that. And we also need open architectures and standards of the different equipment that is installed in the smart grid, such that the different stakeholders acting in the smart grid can work with each other together. They can interact and align with each other. Okay, so these are the 5 categories, and let's go to the KPIs in this context. So the next slide. So with respect to the first category, 3 KPIs have been defined. So counting the number of customers served by ESCO and also the number of services that are offered to them. And then next to that, also one measuring the number of kilowatt hours that the consumer saves because he receives these services from the ESCO. With respect to flexibility, we defined 5 KPIs. So the first one telling the number of customers, offering flexibility to aggregators. Then the next one is looking at the flexibility in megawatt hours that aggregators can offer to market players, and the next one also looking at the time that they can offer certain flexibility. So if you look at shifting the load, for how many hours, for instance, they can shift a certain load. And then there is also one focusing on the extent to which storage and DG are able to provide ancillary services, so able to provide services to the network operator. And a last one focusing on storage and distributed generation as well, but which part can be modified compared to the total storage and DG available. With respect to customer choice, only one KPI, simply the number of tariff plans that is available to consumers. With respect to support mechanisms, so a first indicator telling which percentage of our investments can be recovered through rates or subsidies, and also one looking at which part can be covered by external financing. And then the last one with respect to the interoperability, there we identified one KPI, namely the weighted average maturity level of interoperability realized among electricity system stakeholders. So this maturity level will have to be measured using a kind of interoperability maturity model. This is something that should be developed, but there are examples in literature. For instance, it has already been done with respect to software. You have software capability maturity models, so we could make a similar model for interoperability in smart grids. Next slide, please. Then there is the fourth characteristic, which consists in providing power quality for the 21st century. So also with a smart grid, we want to ensure that people get a good power quality. This is becoming more difficult with, for instance, this renewable energy generation with its often variable and not completely predictable output. So in this part, we identified 3 categories. So the first one is simple power quality. So also in the smart grid, we want to provide our electricity customers with the power quality they expect. Second one is required power quality. Well, in a smart grid, it becomes possible that people differentiate in the power quality that they actually want. It is possible that a large industrial consumer wants a totally different type of power quality than people at a household level want. So it will become possible to contract for different levels of power quality. Then the last category concerns microgrids. So a microgrid consists of different distributed components like loads and generation and storage, and is still connected to the grid, but if needed, so in case the network operator is facing problems, it is able to be islanded from the grid, and through a kind of centralized control, it is able to function as an island, so alone. Okay, let's go to the KPIs in the next slide. Okay, so with respect to the first category, so the one of power quality, we identified 3 categories. So the amount of voltage variations you have in the grid, the time of these voltage variations, and also the percentage of customer complaints relative to power quality. With respect to the required power quality, one KPI, namely the range of frequencies that can be contracted, and also the range of voltages that can be contracted, because frequency and voltage are the main components defining the power quality. With respect to microgrids, we identified 3 KPIs. So the number of microgrids that are really in operation, the capacity of these microgrids, and the total capacity of these microgrids compared to the capacity of the entire grid. Next slide, please. The 5th characteristic consists in optimizing assets and operating them efficiently. If you look at the European grid, we see that most investments were made about 40 years ago, and that a lot of these assets are currently aging. So a lot of reinforcements and investments have to be made, and it's best to do this with the new technologies available to integrate communication, etc., so the smart technologies now. We identified 4 categories with respect to this characteristic. So the first one is transmission and distribution automation. So in a smart grid, we will see that in the transmission as well as the distribution grid, more things will be monitored and measured, everything will be controlled, and you will get automated reactions based on these measurements. And because of this, it will become easier to operate the system closer to its capacity and stability limits. Then a second one is dynamic line rating. So the idea about dynamic line rating is that you will do real-time measurements, for instance, with respect to the weather conditions, with respect to the load, also with respect to the tension on the lines, etc. And on the basis of this, you will real-time define what capacity is available for power flows on each line. Because of this, it will be possible to use your network much more efficiently. Then capacity factors. So the capacity factors in fact describe the ratio of energy that is actually produced or delivered compared to the amount of energy that could have been produced and could be delivered. So this is to give an indication which percentage your smart grid is possible to integrate in its network to host. And then a last category, efficiencies. So this one is focusing on how smart grids optimize the operating efficiency and the utilization of your assets. So for instance, how much energy losses you have in your network. You want to use your network most efficiently, so you want to reduce the energy losses. So next slide, please. So the KPIs that we identified in this respect. So with respect to transmission and distribution automation, we only identified one KPI, identifying the percentage of substations that are active, or in other words, are applying automation technologies. Then the next one, dynamic line rating. With respect to this, we identified 3 KPIs. So the first one, the number of lines operated under dynamic line ratings. Then there is one expressing the percentage of kilometers of transmission circuits operated under dynamic line ratings. And then there is also one focusing on the yearly average transmission transfer capacity expansion that is realized because you use these dynamic line ratings. With respect to the category of capacity factors, so one KPI is the yearly average and peak generation capacity factor. Another one is the yearly average and average peak capacity factor, but for a typical kilometer of a transmission line. And then you have the last category with efficiencies. So there we have 2 KPIs. So the efficiency of generation facilities, so output compared to input, and the amount of energy losses in transmission and in distribution. Next slide, please. Then the last characteristic, so operating resiliently to disturbances, attacks, and natural disasters. In this category, in this characteristic, we identified 4 categories to measure progress with respect to this characteristic. So the first one is advanced sensors. So what we will see in a smart grid is that you will get this kind of wide area measurement systems, or WAM systems. So you will get advanced sensors, be able to measure the status of your system and to measure it in a rapid and effective way. Then the next one, information exchange. When you have a lot of sensors, you have a lot of information, but you should be able to share this information with the market parties that need to have them. So there should be an efficient communication towards the network operators. There should be efficient communication between the transmission and the distribution system operators, and there should also be a kind of information process towards and from the final customer. Then the third category, transmission and distribution reliability. So also in a smart grid, the reliability has to be assured, and specific standards exist to measure this reliability. And then finally, standards in telecommunication infrastructure. So in a smart grid, telecommunication is very important. Now, as communication standards are highly interconnected, it is important that standards arise for monitoring, controlling, and automation, for instance. We see, for instance, that in the United States, the National Institute of Standards and Technology, the NIST, did already an effort in this respect. In Europe, we are only starting with formulating these standards. Okay, next slide. Then KPIs with respect to this last characteristic. So with respect to the advanced sensors, we identified 3 KPIs. So first, the number of grid elements that can be remotely monitored and controlled. Then the percentage of substations in which you can find these advanced measurement technology. And also the number of applications supported by these measurement technologies. With respect to information exchange, we identified 3 KPIs. So the total SCADA points shared per substation, the fraction of transmission level synchrophaser measurement points shared multilaterally, and the performance of communication channels towards grid elements. With respect to transmission and distribution reliability, we used indices that are already quite old, commonly known. So the so-called SAIDI, SAIFI, KAIDI, and MAIFI. So each representing several aspects with respect to interruptions and outage durations. And then finally, the standards in telecommunication infrastructure. With respect to this, we identified 1 KPI. To identify the compliance of electric power industries with European and international telecom standards and protocols. So next slide, please. So this is the methodology we developed. So we identified several characteristics. For each characteristics, we developed relevant categories, and for each of these categories, we identified KPIs. And it are these KPIs that can be measured and that will give you an indication of your overall progress. Now, how can you use the results? Well, you can use them for policy making, so to assess the progress towards a smart grid on a national basis, but also, for instance, on a European level. So, and you can use the results to benchmark between countries or, for instance, to compare the progress in Europe with other continents. Regulators can use the results of such analysis to formulate a good regulatory framework. So there are different possibilities. They can opt for sunshine regulation, meaning that they will determine a set of performance indicator for each operator, so for each operator in each member state, and that they display the results publicly and compare between member states. Another option is going for incentive regulation, so it implies that the regulator will give penalties or rewards for the achievement or non-achievement of a specific target. And finally, the regulator can also opt for direct regulation, so simply imposing a strict target which has to be met by the network operators. It can finally also help this analysis to evaluate project results on smart grids. So for instance, in the beginning of the presentation, I talked about European Electricity Grid Initiative, within which several demo projects are launched. Well, KPIs can also help to evaluate how successful these projects are. It is always important for each assessment that and the results or the actions that are taken based on the results that they encourage progress in each of the 6 characteristics that we defined. Okay, next slide, please. So finally, to conclude, next slide. So we found that at a European level, different initiatives are going on, but that there is not yet a common methodology on how to measure how successful these initiatives are. So there is also not yet a common understanding of KPIs, for instance, and with respect to KPIs, the measurability is sometimes neglected. So what we did in this presentation is listing several KPIs, and we defined them around 6 characteristics as defined by the Department of Energy in the United States. And in each of these characteristics, we clustered KPIs in several categories. So now this methodology is only a starting point. So depending on the initiative you want to evaluate, you will have to refine the methodology. So you will have to organize workshop, surveys, or studies with all the stakeholders concerned to come up with a final, more detailed methodology. So next slide, please. So for instance, in Europe, this kind of further discussion is going on with respect to the European Electricity Grid Initiative. So at the moment, the GRC, so this is part of the European Commission, is working on KPIs to measure the effectiveness of the EGI program. So they are formulating very high-level indicators to measure this, but there is also a demonstration project going on that tries to formulate more specific indicators for clusters of projects. So different technical KPIs and also KPIs on the implementation effectiveness of each of these projects towards the total EGI program. And so for this project, for instance, the K.U.Leuven methodology is used as one of the basic inputs. So next slide, please. So if you would like to have more information on the methodology I just introduced, you can download the full paper at the web link that you can see there. Okay, so this was my presentation. Thank you for your attention.
Okay, thank you very much, Leen. Well, my first impression is that this is the first time I hear about concrete things for smart grids. Till today, I used to hear to smart grids as something, as everything, but nothing really concrete. So today we have seen very concrete lines for what smart grid means and how to measure it. So I'm personally really happy to have attended this presentation. Excellent. So in the meanwhile, I'll invite our audience to type your questions in the Q&A pod, which is well, in the middle of the layout now. And well, in the meanwhile, I'm interested to know a bit more about the participation of customers. So you mentioned dynamic pricing signals, and then I'm wondering whether such a system already exists somewhere in the world.
Yeah, so if you really speak about real-time pricing signals, I don't know whether it exists, for instance, in the United States, because I know they are much further with demand response, etc. But I can speak for Europe, and it does not yet exist somewhere in Europe, but we are doing demonstration projects on it. So, for instance, there is now a demonstration project going on in Denmark, and there they are constructing a kind of real-time market, and there, so each final customer will get a real-time signal every 5 minutes. So not every second, but every 5 minutes. So, but if you compare it with the current situation, for instance, in Belgium, where we have only 2 tariffs a day, it's already a huge improvement.
Okay, and then what happens at customer side? I mean, if I can see the electricity price, then it gives information. So do you think it really influences customer behavior?
Yeah, so there are different also demo projects going on that try to get an idea of how much it influences consumer behavior, but I think it always will depend on how consumers will react, because it's possible that the consumer will not react itself, but that it goes automatically. So that, okay, you get a certain price signal, and at the beginning of the day or at the beginning of the year, I don't know, you submit your preferences to your controller, and then from then on the controller will send automatic signals to your dishwasher, to your heat pump, etc. So then you will get a rather substantial influence of the prices. But okay, if you have to react yourself, and if you don't have this automatic infrastructure, the influence will be less.
Okay,
in Flanders we have, for instance, a project where we are not working with real-time tariffs, but where we work with 5 different tariffs a day. And we are also testing how people are reacting, and we see that there is a kind of 15% moving of electricity consumption.
Okay, which is quite significant. Mm-hmm.
Yes.
Just by simple information signal. Okay.
Mm-hmm.
Okay, great. Okay, I see no additional questions from the time being. So, well, everybody is invited to submit any. So I see the first one coming. So from Roos Conklin. Hello everyone. Question for both our speaker and our audience. What aspects, KPIs, etc. need to be added to the methodology to address circumstances in emerging developing economies? So maybe I repeat the question. What aspects need to be added beyond the KPIs to the methodology to address circumstances in emerging developing economies? So this is another way to ask the question is this is easy to figure out in Europe, for instance, but what can be done in other emerging economies? I don't know whether, Leen, you have covered at any time this aspect for other regions.
Yeah, I think it's a very interesting question, but I'm afraid I'm not able to answer it. So the KPIs that we developed, so we started a little bit from characteristics that were defined in the United States, and then we tried to develop this KPI mechanism, but it was mainly focused on the European situation. So I completely agree that if you want to use this methodology for emerging developing economies, you will have to make certain adaptations, but I have to admit that I'm not very aware of which KPIs you would have to change, which you would have to add, because I'm not fully aware of the status in different developing economies.
Okay, thank you, Leen. Meanwhile, I have another question. Sorry to abuse from my position. I also invite audience to submit additional questions. Do you have an idea of prosumers in Europe? How far has penetrated the centralized generation, for instance, CHP in buildings, or photovoltaics integrated, or roof installed photovoltaics? Do you have an idea on how far are we today, and if we have the required regulatory and administrative framework to allow consumers to inject power into the grid? How good is the situation, or how many progress have we to do?
With respect to figures concerning how much distributed generation and how much prosumers we have at the moment, that's rather difficult. I can give one example, for instance, in Europe, which is Denmark. This is a very advanced country in this respect. We can see there now that at the moment there is more capacity connected to the distribution grid and to the transmission grid. So only a few years ago they had a completely centralized system with only generation connected to the transmission grid. But now you can see a really different situation there. But I think the integration really depends from country to country, and as you say, it also depends largely on the regulatory incentives that are given, but they differ between the member states. So if you look at Belgium, for instance, we had a lot of subsidies for the installation of PV panels. So we really see that there was an enormous rise in PV panels the last years. But now we see that it's getting difficult for our grids. They are not yet smart enough, so we are facing grid problems at a distribution level, and so now the subsidies are going down for these PV panels. But I think, yeah, the story is different for each member state, as each member state is allowed to set its own regulatory framework.
Mm-hmm. Mm-hmm. So there is probably something to be done to harmonize, or at least to withdraw barriers for distributed generation at small scale, just beyond the subsidies, and beyond, so we need that the grids can accommodate the flows, and we need also some regulatory push.
Yeah, it depends for which there are technologies like, for instance, PV panels, of which the price has gone down significantly. So maybe it's correct to say that we don't need to subsidize them to the same extent anymore. So it depends from technology to technology, I think. But it's true that, it's mainly the grid that has to be accommodated, because, it's a little bit kind of strange of subsidizing this kind of technologies, but not making any changes to your grid.
Yeah, so I think it's quite related to country-by-country basis. Recently in Spain there has been published something about net metering, so giving consumers the possibility to inject power to the grid, but well, in principle always with an annual net balance equal to zero or net consumer. Okay, so I think we are just starting the way, and we will see many progress in the coming months and years. Excellent. In the meanwhile, we have a comment by Nikos about the previous question. So I guess for emerging economies, it would be more difficult to collect the data for the already defined KPIs rather than impose certain new. So just, I think, complementing or commenting on the previous question. Very well. I don't see new questions coming. I think that well, the next session in the afternoon in Europe will be definitely more populated, so most of questions will be probably concentrated there. So, well, I suggest we hereby adjourn. So thank you very much, Leen, for this excellent presentation. We have now a much more clear idea of what smart grids can mean, and how we can well, measure the progress through smart grids around the world. So on behalf of Clean Energy Solutions Center and Leonardo Energy, I would like to well, thank you all for your participation in today's webinar. We have had a great audience from all around the world, and well, we very much appreciate your time. So please check the Solutions Center website. As well, you have the link for a Leonardo Energy website. As we will upload soon the presentation and the webinar recording. So we also invite you to frequently check the training page of Clean Energy Solutions Center for upcoming webinars and other training events, and to inform those in your networks about these initiatives, the Solutions Center and Leonardo Energy, their resources and services. So have a great rest of your day, and we hope to see you again soon on future Clean Energy Solutions Center events or Leonardo events. Thank you very much. So thank you, Leen. I let you close the session.
Okay. Thank you. It was a pleasure.
Okay. So have a nice day, everybody. Thank you very much.
Okay. Bye.